Welcome back, everyone. So today we're going to talk about histograms. And histograms are another visual representation that we can use to describe and talk about statistics and talk about data sets that we get when we're studying statistics. Okay, and so a histogram is simply a bar graph that's used to display the frequency of certain data values that we're given, but we display it in equal intervals. Okay, and so that's one of the things that I want when we're creating these histograms, we want to be very careful that we do it correctly. So for instance, here's a histogram of scores on a math test. Let's say we took a test in class and I wanted to create a histogram of your scores. So what you must be careful of is that you want to make sure that you label your X and your Y axis. In this case, the X axis is going to be the test scores, and the Y axis in most cases on your histograms is the frequency. Okay. Also, you want to make sure that you have equal intervals on the X axis. So here we can see that our scores range from 60 all the way up to 99. We don't know the exact scores on the test for each student, and we don't, but we know the range. Okay, and so when I say equal intervals, notice that we have from 60 to 69, so that's increments of 10, 70 to 79, another increment of 10, 80 to 89, and so forth. So you want to make sure that your intervals or your increments on your x-axis are equal. Okay, make sure that you label your axes correctly and that you make sure that your y-axis labels the frequency correctly. Another thing that you want to be careful and you want to make sure of when you're creating these histograms is that your bars are even. So your bars must be even in width, and they must touch but not overlap. So there can't be any orange in the blue area or any blue in the green, etc., because that would mean that your data values are overlapping somehow and that your increments are not correct. Okay, so make sure that they're not overlapping, but that they are touching and that your bars are even. Okay, now let's take a look at an example. Here we have the ages of 100 US senators at the start of the 112th Congress on January 3rd, 2011. And we want to create a histogram for this data set. First, let me back up for a second. Let's go back to the first example. So there are things that you can, there's information that you can pull from a histogram as well, just like we've seen with dot plots and with box and whisker plots. So of course you can tell the frequency. So for example, the frequency of students that scored between 60 and 69 would be about 3. Okay, the frequency of people that scored between 70 and 79 is 9. For here, between 80 and 89 is 12, and between 90 and 99 would be 7. Okay, so you can tell the frequency or the number of times that people scored within this within the range of 60 to 69, 70 to 79, etc. But like I said earlier, you cannot tell the exact score that they made. If we wanted to, another thing that we can tell is the total number of students that were tested, and we can do that by adding up the frequencies. So in this case, we would have 3 plus 9 plus 12 plus 7, which gives us a total of 24 plus 7 is 31. So we know that in total 31 students were tested, and we have 31 test scores here. Okay, so here we have an example where we have the ages of 100 US senators at the start of the 112th Congress, and we want to create a histogram for this data set. So when you want to create a histogram for a data set this large, the first thing you're going to do is you're going to create a frequency table. And so most of your frequency tables will have increments of 10 on the x-axis. So remember, the age interval, this is the x-axis. and your frequency is on the y-axis. Okay, and we can see that here we have the histogram for this set of data, and the ages are in increments of 10, and your frequency is along the y-axis. Now, remember, so we can tell the frequency from a histogram. We can tell the frequency of each increment of data values. Secondly, what we can tell is the distribution of our data. Remember, in the previous lesson, we discussed dot plots, and we discussed whether the data distribution was skewed to the left, skewed to the right, or whether it was symmetric. In this case, our data here is symmetric because the majority or the chunk of our data is in the middle of our histogram. Okay, now, you're going to be given histograms where you have a frequency table. Sometimes they'll give it to you with the data values, but most of the time they'll give it to you with the frequency table. And then you have to create the histogram. From this, since we don't know, as I stated earlier, since we don't know the exact values in these increments, we can just find frequencies. You can estimate what your mean and median values will be. You won't find an exact, but you can come very close to what your mean and your median values will be. Now, to do that, for the mean value, what you want to do is you want to take the midpoint of each increment. Okay, so if I were to take the midpoint of the first increment, that would be 39 minus 30 over 2. Okay, and that would give me 9 over 2, which is 4.5. But this is just your midpoint. To find your actual midpoint value, you have to add your lowest, the lowest value in that increment, which is 30. So our midpoint for the increment between 30 and 39 would actually be 34.5. Okay? So we take that midpoint and we're going to multiply it by the frequency for that age interval. So in this case, it would be 2. Now, if we wanted to find the increment for the second interval, it would be, each one is going to be 4.5. So you just have 4.5 because these are all increments of 10. So each midpoint is 4.5. So 45 times 10, 44.5 times 10. Then we're going to have 54.5 times 30. 64.5 times 37, 74.5 times 18, and finally 84.5 times 3. And if we were to find the sum of these, we'd get a sum of 6,130. Now, to find the mean, we must divide this sum by the total number of values that we have. And so we know that in this data set, there are 100 US senators. So the mean would be 613 divided by 10 because these two zeros cancel. So we get 61.3. And so what this tells me is that on the average age for this set of 100 US senators is 61 years old. Okay, now if we wanted to find the median for this set of data, what you're going to do is you want to find that middle value, right? So remember in the previous examples, what we did was we took the total number of values in our data set. So in this case, it would be 100, and we divided by 2. And so we get 50. Because we have an even number of values in our data set, we must take the average of the 50th and the 51st value. Okay, now to find that, we must add our frequencies. So here we have 2, 10, the frequency for this increment is 30, so that's 30, 40, 42. So our median lies somewhere in this 60 to 69 increment. Okay, so now it would be, we had this total was 42. So that means if we need to go to our 50th, so that's 8. So it's going to be about the 8th. We need the 8th and the 9th term in this increment set. So in order to do that, we need to figure out what percentage of this increment will get us to the 8th or the 9th data set. Now, we know that in the increment 60 to 69, we have 37 values. So between 60 and 69, we have a frequency of 37. All right? And so to estimate how far into this interval we need to go, we're going to take the average. Remember, we need the average of the 8th and the 9th. So the average of 8 and 9 is 17 divided by 2 is 8.5. Now, we're going to divide this 8.5 by 37 because that's the frequency of our increment between 60 and 69, and that gives us approximately 0.23 or 23%. Okay, so 23% of that increment of 10 is going to get us to our 8th and 9th value. So we want 23% of that increment, and we know that increment is 10, and then we're going to add our lowest value in that increment, which is 60, and that will give us our median value. So when we do that, we get that our median value is approximately 62. Okay, and so this is a little higher than our mean value, but it's still in the range that we know that the middle value for our 100 US senators is 62 years old. Okay, and so today we've looked at how to construct a histogram and what a histogram tells us about our data set, and how we can pull certain information as far as the mean and the median and the frequency. And we also looked at the distribution of our data looking at a histogram. Okay, and so that's the end of today's lesson.